myself is Shravani. Now I am going to give some simple tricks for the naming of bicyclo and spiro compounds. First, in order to know about how the naming for bicyclo and spiro compound takes place, before that we should know what are bicyclo compounds. The name itself indicates bi means 2, whereas cyclo means rings. That means a compound must contain 2 rings in it, and there must be a condition that 2 rings must require at least 2 common atoms. Okay, then how can you define these bicyclo compounds is that the compound that contains 2 rings with at least 2 common atoms are known as bicyclo compounds. Okay, here I have taken 2 examples to explain what are bicyclo compounds. Firstly, observe this first compound. Here we are having 2 cyclohexane rings, right? And these 2 cyclohexane rings contains these 2 carbon atoms are in common. That means it satisfies the condition of bicyclo compounds, right? A compound that contains 2 rings with 2 common atoms, and these 2 rings are fused at these 2 carbon atoms, right? And hence this type of bicyclo compounds are known as fused bicyclo compounds. Okay, these are a type of bicyclo compound as the 2 rings are adjacent to each other which are in fusing position, and hence it is known as fused bicyclo compound. Here I have taken another example. When you see it, we think it is difficult. So first we have to convert into simplest form. To convert into simplest form, these carbon atoms which I am circulating here, these 2 carbons acts as bridgehead carbons. The reason is that at these 2 carbons only bridging takes place. That's why these carbons are known as bridgehead carbons. Okay, from these bridgehead carbons only we need to give numbering. Either we can take in clockwise or anti-clockwise direction. Here I am taking clockwise direction. 1, 2, 3, 4, 5, 6, and then 7, 8. So here first we have to take 6-membered ring, cyclohexane ring. Just give the numbering the same. This is one of the bridgehead carbon. 1, 2, 3, follows the same order. Here also I am taking in the clockwise direction only. 5, 6. Now the bridging takes place at first position and fourth position with 2 carbon atoms, right? First 1, 2. So it is I am giving as 7 and 8. So when we consider here also we are having 2 rings, but here they are not getting fused, but here bridging will takes place. It satisfies the condition of bicyclo compound, but instead of fusing, here bridging takes place. That's why this type of compounds are known as bridged bicyclo compounds. Okay, these are the classification involved in bicyclo compounds. Okay, now in order to know about how the naming for this bicyclo compound takes place, we are having some certain amount of rules. What are the rules is that first, numbering starts from bridgehead carbon of largest ring to shortest ring. For example, I am taking this as an example. Here the 2 rings are of same size, right? If I am taking another example having 2 different rings, one see here it is having 2 different rings of 6-membered ring and 5-membered ring. In that case we have to consider preference has to be given for largest ring. and the numbering has to be starts from bridgehead carbons. These two are bridgehead carbons. Okay, so the numbering has to be given first at the bridgehead carbon and to the largest ring. So 2, 3, 4, 5, 6. Now continue up to the shortest ring. 7, 8 and 9. This is how the numbering has to be given. Okay, is it clear? Next rule is that the prefix for this bicyclo compounds has to be like bicyclo XYZ. We have to know what are XYZs. XYZs are nothing but carbons other than bridgehead carbons. That means leftover carbons of bridgehead carbons. Okay, and it must be in the order of X, Y and Z. Okay, next the root word is which comes as a suffix, that must be total number of carbon atoms. Okay, this is the whole rules we need to follow for the naming of this bicyclo compounds, and it has to be like, what is the prefix here? Prefix must be bicyclo. It has to be starts with the bicyclo. X, Y, Z. X, Y, Z are carbons other than the bridgehead carbons, and the suffix root word is total number of carbon atoms. So this is how the naming happens. Okay, now I will give some of the few examples so that it is easy for you to identify. Okay, here I have given the same example that I have taken before. So firstly, numbering has to be starts from bridgehead carbons. These two are bridgehead carbons, right? Okay, as these two rings are of the same size, there is no difference, and either any way you can take it. I am taking in this way: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so the prefix must be like what the prefix has to be? Bicyclo X, Y, Z, and the suffix has to be total number of carbon atoms. Number of carbon atoms. Okay, this is how the naming takes place. When you consider here, it is also bicyclo. So first it has to be started with as bicyclo. What is meant by XYZ? XYZ means other than the bridgehead carbons. Here, as the two rings are of same size, other than these two carbons, here it contains 1, 2, 3, 4 carbons. Other than these two carbons, here this ring also contains 4 carbons. So there is no difference. If it contains 4 and 3, then preference has to be given for more number of carbon atoms. As these are of the same size ring, that's why 4 dot 4 dot. Is there any bridging here? No. So 0. Okay, if there is bridging, that bridged atoms has to be considered here. 0. Total number of carbons 10. So it is decane. Is it clear? Next example. Consider the next example. Here also, first we have to start numbering from these bridging carbons. Yes, here the rings are of different size. The preference has to be given for higher ring, larger ring. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so it has to be, namings has to be starts as bicyclo X. X means in these two rings, this ring size is higher. Here total it contains 6 carbon atoms. other than this, other than these 2 bridged head carbons, it contains 1, 2, 3, 4. So 4. Here we are having 3. Is there any bridging here? No. So 0. What is the root word? Total number of carbons. Total number of carbons is 9. As there is no double bond or triple bond, simply we have to write it as known aim. Okay, is it clear? Now I am taking some other examples. See here it is like this. We have already known that this one is one bridgehead carbon, this is another bridgehead carbon. If you find it is difficult in this manner, you can convert it into simple manner like I taught you before. Okay, or otherwise you can write like this only: 1, 2, 3, 4, 5, 6, and the other preference gives to 7. Okay, if you find it is difficult, then convert it into simplest form. Here we are having 6 carbon atoms, that is cyclohexane rings, with 1, 2, 3, 4, 5, 6, and the bridging takes place at first and fourth position with 1 carbon, that is 7. Okay, is it clear? Now we have to consider the naming. Here also bicyclo X. X means other than this bridgehead carbons, how many number of carbon atoms are there. Here in this ring, other than this bridgehead carbons, we are having 2 carbon atoms, right? 2. Here also in this ring, other than this bridgehead carbons, we are having 2 carbon atoms, 2. And what is meant by Z? Z is involved if there is any carbon acts as bridge carbon. Here this 7th carbon acts as bridge head carbon, that means 1 carbon, 1. Okay, total number of carbons are 7. As there is no double bond or triple bond, simply heptane. Okay, next example. These 2 are bridgehead carbons. First, initially identify the bridgehead carbons and then give numbering. From that only it is easy for us for the naming of these bicyclo compounds. 1, 2, 3 and 4. Okay, bicyclo. What is meant by X? Here these 2 rings are of same size, right? Here also 3-membered ring, here also 3-membered ring. Other than these 2 carbons, we are having 1. So X is 1. Here Y is also 1. Is there any bridging carbon here? No. So that can be considered as 0. Total number of carbon atoms here is 4. 4 means you have to write it as butane. So I think it is more clear for you to identify for the naming of this bicyclo compounds. It is easy for you. Okay, now I am taking some more difficult. That means I have added some substituents. Here first we have to identify the bridgehead carbons. These 2 are bridgehead carbons. Then go for the numbering. As this is a 6-membered ring, the preference gives to 6-membered ring. 1, 2, 3, 4, 5, 6, 7 and 8. We have already known that according to IUPAC, the substituents must be comes first. Before the prefix only we have to give in the substituents. At 7th and 8th positions we are having substituents, and that substituents are methyl groups. So it has to start as 7, 8 dimethyl. Now the naming is as usual, bicyclo. X must be largest string carbon atoms other than these bridgehead carbons. Other than these bridgehead carbons we are having 4 carbon atoms. 4. Here we are having 2. 2. Is there any bridging carbon? No. So 0. Total number of carbon atoms is 8. So octane. Okay. Next, I have given some alkene position here. Okay. Now first initially we have to identify the bridgehead carbons. Now we have to give the numbering, but these two rings are of the same size, so there is no difference. But here is a difficulty is that here we are not having any substituents and any other functional group, but in this ring we are having a substituents and functional group, that is alkene. We have already known that according to nomenclature the substituents must give in the lowest numbering, because here the two rings are of same size. If it is of different size, it is different. Okay, in that case we have to consider some other. 1 2 3 4 5 6 7 8 9 and 10. Okay, first we have to give substituents name. At third and fourth position we are having methyl groups. 3, 4 dimethyl, bicyclo. Other than these bridgehead carbons, we are having 4 carbon atoms left here. 4. Here also 4. Is there any bridging? No. 0. Okay. Total number of carbons is 10. That means dec. But here we are having ene position is existing here. So dec 3 ene. Is it clear? Okay. From this I think it is easy for you for the naming of bicyclo compounds. And next our topic is spiro compounds. Here I have taken some other example. Once see, just observe these two compounds. Here we are having 2 rings of different size, whereas here we are having 2 rings of same size. But here the 2 rings have 2 common atoms, right? Whereas here we are having only 1 common atom. Okay. If we are having 2 rings with the 2 common atoms, then such compounds are known as bicyclo compounds. Okay, just come with a name. We have known that when compared to the 6-member ring, 4-member ring is of lower number. That's why preference go for the 6-member ring. 1, 2, 3, 4, 5, 6, 7 and 8. Come, bicyclo. Other than these 2 carbons, in case of largest ring we are having leftover carbons of 4. 4, 2. Is there any bridging? No. 0. As total number of carbons is 8, it is known as octane. Okay, but here in this case we are having 2 rings of same size, but it contains only 1 carbon as a compound. Then such compounds are known as spiro carbons. What are they? They are known as spiro compounds. Okay. Just come here. Then how can you define this spiro compounds is that the compound that contains 2 rings with 1 common atom. Okay, here we are having 2 rings with 1 common atom. Okay, then such compounds are known as spiro compounds. Just like for the naming of bicyclo compounds, here for spiro compounds also we are having some set amount of rules. What are the rules is that? What is the first rule? Numbering has to be starts from bridgehead carbon of shortest ring to largest ring. It is just an opposite to the bicyclo compounds. In that case, the preference has to be go for largest ring, whereas here it has to be go for shortest ring. Okay. For example, if you are having a compound like this is the bridgehead carbon. Okay, common carbon. Okay. Here we are having 5-member ring and 4-member ring. The preference has to be given for first 4-member ring only. Okay. and here the prefix has to be starts as spiro XY. In case of bicyclo compounds, the prefix is bicyclo X, Y and Z. There the bridging happens and hence Z is present. Here there is no chance for the bridging. That's why there is no Z here. Okay. What is the root word here? Root word is comes as a suffix. What is the root word? Same. The total number of carbon atoms. Okay. Let us see some examples so it is easy for you. Here I have taken this example. This one is a bridgehead carbon. The numbering has to be starts from here. As it is a spiro compound, the numbering must be preference has to be given for shortest string. So 2, 3, 4, 5, 6, 7 and 8. Okay. Now it has to comes out as spiro. What are XY? Other than the bridgehead carbons, the leftover carbons in the shortest and longest string. First X has to be shortest string carbons other than bridgehead carbons. Y means leftover carbons other than bridgehead carbons. Okay, in shortest string other than this bridgehead carbons we are having 3 carbon atoms. 3 dot. Other than this bridgehead carbon in largest string we are having 4 carbon atoms. So 4. Total number of carbons 8. So octane. Okay, so totally we have to write it as spiro XY number of carbon atoms. Okay, now I have taken another example. See, this is the bridgehead position. We have already known that in case of spiro compounds, the preference has to be given for shortest string. So the numbering starts from here. 2, 3, 4, 5, 6, 7, 8, 9 and 10. Come. Spiro. Say X is the number of carbons other than bridgehead carbon in shortest string. Shortest string that is 3. Here other than this bridgehead carbon, number of carbons in largest string. So here we are having 6. Okay, 3, 6. Total number of carbons is 10 as there is no alkene or alkane. So decane. So from this I think it is definitely helpful for you for the naming of bicyclo and spiro compounds. Thank you.